Hey guys, welcome back to my channel. How's it going? In this video, we'll explore the fundamental principles of counting and how tree diagrams help us visualize and understand the combinatorial problems. Combinatorial analysis emerged from humanity's need to count complex arrangements efficiently. From ancient trading systems to modern computer science, the ability to systematically count all possibilities has been crucial for solving real-world problems. So it's more about counting large numbers. When you cannot just count all these numbers by yourself, you just rely on more advanced mathematical techniques to solve these issues. Today, it is essential in fields from probability theory to artificial intelligence, where understanding all possible outcomes is fundamental to making optimal decisions. Now let's start with a simple example. Imagine you're at an ice cream shop where you first choose a cone type, waffle or sugar cone, and then you pick a flavor. Could be vanilla, chocolate, strawberry, or mint. How many different combinations can you create? While it may seem straightforward, it actually illustrates the fundamental principles that applies to much more complex scenarios. Fundamental principle of counting states that if we can do one thing in n possible ways, or n1 possible ways, and the second thing we can do in n2 possible ways, and so on until the nr. In this case, we can accomplish all r things in a sequence of n possible ways, which equals n1 times n2 times n3 times nr. So this is essentially the total number of ways in which you can accomplish the final result. In our given example, it will be the ice cream. For our ice cream example, the first choice has essentially two cone types, and 1 equals 2. And then we need to choose the flavor. The flavor has 4 different ways. Therefore, the total combinations will be equal n1 times n2, which equals 2 times 4 equals 8. So we have 8 possible ways to accomplish this goal, to choose the proper ice cream we want. Now that we have this established, let's move to our next point, which is the visual representation of our choices. To better understand the principle of counting, we can rely on visual representations of that, and mathematicians use tree diagrams. These diagrams are particularly helpful because they can show all possible outcomes clearly, they illustrate the sequential nature of choices, and they make it easy to count all total possibilities. Let's draw a tree diagram for our ice cream example. So first we need to choose the root node. In this case, we have two possible cones, two cone types, the cone type C1 and the cone type C2. Suppose the C1 will be the waffle and the second type is the sugar one. Each branch, C1 and C2, creates a new node, leads to a new node. And from this node, we can also have 4 different types of flavor. So we need to illustrate 4 more different types of flavor. Flavor type F1, flavor type F2, flavor type F3, and flavor type F4. I definitely needed more space here, but it still works. F1, F2, F3, so 4 different types of flavor. And the same goes for the cone type C2. F1, F2, F3, and F4, and 4 different nodes for this one. So in total, we have 8 possible ways to achieve the final result. We can even go over them. So this is the first possible way, the second possible way, the third possible way, the fourth one, the fifth, the sixth, the seventh, and the 8th. And each path here illustrates a unique ice cream combination. In total, we have 8 possible outcomes, 8 possible combinations of the cone type and the flavor type. This principle extends beyond simple food choices. It can be applied in pin numbers, like 10 choices for each number. Suppose we have an example of the pin number which consists of 4 different digits, where each digit is essentially a number from 0 until the 9. So suppose we have 3-digit pin code. In this case, the first digit might have 10 possible outcomes from 0 until the 9. 10 possible outcomes for the first one. The second digit can also take 10 possible outcomes, and the same goes for the third digit. Now in total, we would have 10 to the power of 3 of possible combinations, which equals 1000. So our pin code has essentially 1000 possible outcomes, 1000 possible combinations of the pin codes. This principle of counting has also applications in other fields of science, like DNA sequences, 4 choices for each position, computer passwords, varying choices per character. The fundamental principle of counting and tree diagrams provide a powerful framework for solving counting problems. In our next video, we are going to explore how this principle connects to permutations and combinations. But first, we're gonna solve some practical challenges related to all the stuff we already covered at this point. And again, thank you for watching this video. I hope you found this video helpful. If you have any questions or suggestions, please leave them in the comment section below. I would appreciate your feedback. For more technical discussions, please join our Discord community. You'll find the link in the description. You can also connect with me on LinkedIn just to stay updated on future contents or any other discussions. See you in the next episode, and as always, take care.